Hey guys, welcome to Homework Help for Year 7, Term 3, Week 3. On page 19, we're doing Set 6, Question 5. Calculate the remaining volume in each solid correct to one decimal place. All measurements are in centimeters. Centimeters. Okay. So, what I'm going to do is I'm going to find the area of this shaded region and I'm going to multiply all the way down by 14. So let's find the area of that shaded region. So basically it's just the area of the big circle minus the area of the small circle. Okay, so the area of the big circle has a radius of 5.2 centimeters. So the area of the big circle is equal to let me see, area is pi r squared, r is 5.2 squared. Okay, and the area of the small circle is going to be equal to pi times radius squared. Radius is 4.8 squared. It's a bit hard to see, but yeah, there's your 4.8. So that means the area of the big circle, let's say 5.2 squared, is going to give you 27.04. Okay, all I did was just square this one. I didn't multiply by pi or anything yet. So therefore we still have to multiply by pi, so I'll just leave that in there. The same thing I'm going to do 4.8 squared, and I'm going to get 23.04 pi. Okay. Now I'm going to take the area of the big circle, so the area of the shaded region is the big circle minus the area of the small circle. So that's going to equal to 27.04 pi take away 23.04 pi. So now that's going to equal to 27.04 take away 23.04, and they'll give you 4 pi. That's all you get. So all you have left is 4 pi. That means this shaded region, the area of this shaded region is 4 pi. This is your 4 pi. Now the area of this solid, okay, so not the area, the volume. The volume of this solid is equal to the 4 pi multiply, that's the cross-section area, by the way, cross-section area. That shaded region is the cross-section area. So I usually like to find the cross-section area and then multiply by however long or high it is. In this case it's 14, so multiply that by 14 and you're gonna get 56 pi. Yep. So this is the exact answer. Okay, this is the exact answer. If the question asks you to find the exact answer, you leave it like 56 pi. Once you multiply by pi, it's no longer exact. It's because pi is irrational number. So when you multiply by pi, you can do 56 times pi. And you're gonna get the answer is 175.93 to 2 decimal places. If now this number goes on forever, it's irrational, so it keeps going on forever. It doesn't repeat or anything. So that's why this is an estimation. Now this is the exact. Okay. Alright. So we got the answer to be all measure. It says to 1 decimal place, so that means the answer has to be 175.9. Now that is for that question. For the next question, I'm going to clear this. Okay. For the next question B, I'm going to find the area of the cross section. Now you have to determine where's the cross section. The cross section is this one here. Alright, so let's find the area of this cross section. Now we have a, let's do, what I'm going to do is I'm going to find the area of this entire circle minus the area of this circle, and then I'm going to halve it. Looks like a Pokeball now. Okay, so let's find the area of the big circle. Now we know that the big circle has a diameter of 9 because this is 9 here, so that means diameter must be 9. So the radius must be 4.5. So the radius is 4.5. So the area of the big circle is equal to pi r squared, remember? Pi times r squared. R is 4.5 squared. Now 4.5 squared is going to give you 20.25 pi. I'm going to leave it in exact form. Now the area of the small circle is equal to pi times what's the radius of the small circle? Now we know this is 4.5, okay, and this is 3, so the radius is, when we take 4.5 take away 3, you're going to get 1.5. So that's 1.5 squared, and that's going to give you 2.25 pi. I left it in exact form. I didn't multiply the pi, I just left it there. So now we just take the area of the big circle minus the small circle. So what's that? Take away that, you're going to get 18. Exactly 18 pi. Now 18 pi is if we had this. Whoops. If I had the whole circle of that, and that's the area of this. This is 18 pi. But we don't have the whole thing. We only have half of it. So again, we have to divide it by 2. Divide this by 2, you get 9 pi. So the area of this cross section is 9 pi. Now we have to multiply it by how long we're stacking this cross section area down. So that means we do 9 pi. So the volume is equal to 9 pi times by, what's that number? 19. Times it by 19. And you're going to get 19 times 9 will give you 171 pi. There's your volume in exact amount. 171 pi. But they don't want it in exact form, they want it to correct to 1 decimal place. So do 171 times it by pi on your calculator, and you will get the volume is equal to 537.21. Now it says correct to 1 decimal place, so that means the answer is just like this. There's your and this is in centimeters cubed. Volume is a unit, is a cubic unit. So remember to put it in cubic units. Alright, next one. I am going to find the cross-section area, which is this area here. Okay, this is your area. If you don't recognize that's the cross-section area, just find the volume of this cube, take away these 4 cylinders that has been carved out of the cube. Okay, you can do it that way too. I'm going to do the cross-section area way. So I'm going to find the area of this face. Now we know this is 12, this is 12, that means the area of this square is, the area of the square is equal to 12 times 12 equals to 144. Now the area of one circle, let's find the area of one circle. We know that one circle has a diameter of 4, which means the radius must be 2. So the area of the small circle is equal to pi times radius, which is 2 squared, pi r squared, which is pi times 2 squared. That gives me 4 pi. Now we have, that's the area of one circle. Okay, so one circle is going to be 4 pi. But we got 4 of them, so we do 4 times 4 pi, you're going to get 16 pi. So the area of all circles is equal to 16 pi. Now, to find the area of the bits that remain after we subtract it, we just have to do a little subtraction, okay? So we do the area of the cross section. This face is called the cross section area. So this is the cross, actually just write it here. Cross section area is equal to, we take the area of the square, which is 144, take away the area of the 4 circles, which is 16 pi. Okay, and we're just going to leave it like that. We're not going to do anything because these are not like terms. You cannot minus these numbers. You can't take 144, take away 16 and get some answer with pi in it. No. Okay, this one doesn't have pi as a multiple and this one does. So you can't, these are not like terms, you cannot add them. Whoops. Okay. So the cross section area, I'm going to call it CSA. Cross section area is either that. Now to find the volume is the cross section area multiplied by the how long we're stacking it. Well, we're stacking it this way, 12 times it by 12. So volume is equal to 144 take away 16 pi, and we multiply that whole amount times it by 12. Now I can put the 12 on the front here. 12. So volume is equal to that. Now if you're asked to find the exact volume, you can just expand this, okay, and we can say 12 times 144, that'll give me 1728. Take away 12 times 16, and that'll give me 192 pi, and that will be your exact volume answer. But if you want the answer with decimal places, it says here to 1 decimal place. Okay, put this into the calculator and let's see what we get. So 1728, type that in the calculator, press minus 192 with a pi at the end, and you're gonna get an answer like 1124.8. Now what's the units? Is it centimeters? Yes, centimeters cubed. There's your volume. There's your estimated volume, and there's your exact volume. Alright, next question. Question 6. Tina and Steve's wedding cake had 3 tiers, each 9 centimeters high with diameter 22 centimeters, 28 centimeters, and 40 centimeters. Okay, I need to rub this stuff out, so just to make room for this next working out bit. Okay. Okay, so we know that each of these is 9 centimeters high. And the diameter of each cake, the diameter of this one is the largest one, this is 40. This one is 28, and this one is 22. So it says find a total volume of the cake correct to 1 decimal place. So that means we have to find the volume of each cylinder shape part, and we add it together. So I'm going to call this volume 1, volume 2, and volume 3. And what we want to find is the total volume, the V total. It's going to equal to volume 1 plus volume 2 plus volume 3. So let's find out what volume 1 is. Now we know the diameter is 22, which means the radius must be half of that, which is 11. So volume of this cylinder is going to be, remember, the volume of a cylinder is pi r squared times the height. So we do pi times r squared, which means 11 squared, times the height, which is 9. And that's going to give us an answer of... let me just move this around here. Now 11 squared is 100. Let's just do 11 squared. 11 squared is 121, times it by 9, and that will be 1089 pi. Now let's find the volume of, let's find V2. V2 again is pi r squared times the height, which means pi times, let's see what the radius is, because we need to find r. Now the diameter is 28. Okay, so the radius must be half of that, which means it's 14. So that's going to be 14 squared times it by 9. So put that into the calculator, 14 squared times 9, and you're going to get 1764 pi. Now V3, that's the volume here, equals to, again, pi r squared times the height. That means pi times r squared. Now the diameter of this bottom part of the cake is 40, which means the radius must be half of that, which is 20. So 20 squared times it by 9. And that's going to equal to 20 squared times 9. Put on the calculator, you get 3600 pi. Now everything, just remember, everything is still in terms of pi. I haven't multiplied the pi in yet because I want to give an exact answer first. So if we want to add all this together, what we're going to do is add V1, which is 1089 pi, plus V2, which is 1764 pi, plus V3, which is 3600 pi. And now we're going to add them all up and leave it in terms of pi. We can add these up actually because they're the like terms. They all have pi in them. Just like if we add 3x plus 2x. You see they both have x, multiples of x in it, and we can add them equal to 5x, right? So these are like terms, we can add them up. So let's see what we get. So 1089 plus 1764 plus 3600, and that'll give me 6453 pi. This is the exact volume of the cake. Now if you want to find the decimal equivalents, so it says to one decimal place, put it into the calculator, do that 6453 times it by pi, and you get the answer. I'm not going to write it in, you can do that yourself and put it into one decimal place. I think I've been giving away too many answers in here. Alright, question 7. A cylindrical flower pot is packed tightly into a box as shown. 7a, the volume of the flower pot correct to one decimal place. You want to, let me see, cylindrical flower pot. Oh, okay, so the flower pot is the cylinder. It just wants you to find the volume of the cylinder. You can do that. Volume cylinder is pi r squared times height. What's r? Well, we know that this is the diameter. Diameter is also this length here, which is this length here, which is 8.4. So diameter is 8.4. That means the radius is half of the diameter, 8.4 divided by 2. And you're going to get a radius is equal to 4.2 centimeters. So just plug that into the, oh, by the way, the height is equal to 22. So plug that into your equation. So pi times 4.2 squared times 22. Get a calculator out, work it out. Question B says, find the volume of the box. Oh, the volume of the box is easy actually, because the box is just a square prism. Okay, I'm gonna write this out, I'll show you. The box is just this thing here. This is the box. It's a square prism, and the bottom, the base is a square. Okay, so just to find the volume of this square prism, just find the area of the square, multiply by the height. Done. Now C, what percentage of the volume of the box is taken up by the flower pot? So to do this, we need to find the volume of the flower pots and find the volume of the box, which is your answer to A and B. Okay, and then what you're going to do is you're going to divide it. You're going to take the top number divided by the bottom number, and you will get, and this is how you compare something. You're comparing, let me see, and this, so when you do this division, you're going to get 0 point something. Okay, and so let's pretend that the answer was 0.3, for example. That means, nah, actually it shouldn't be 0.3, maybe 0.70 or something like that. So all you gotta do is, this is a decimal, to get to percentage we multiply by 100, so that will be 70%. 70% of the box is taken up by the flower pot, for example. It says what percentage of the volume of the box is taken up. Yeah, so that's the answer. That will be the answer. But obviously I'm just guessing the answer is 0.7. It's most likely not. So you find out what that is and get the percentage by multiplying the decimal by 100. It's gonna be 0 point something. Okay, I can tell. Now question 8 says 4 cylindrical tins of soup have been packed into a box with dimensions as shown. Find the volume of the soup in the box correct to the nearest centimeters squared. Cube, sorry. Okay. So let me see. What I'm gonna do is I'm gonna find the volume of 1 can of soup and then just multiply by 4. So let's call this V1. So V1 is equal to, actually, yeah, so V1 is equal to what? We need to find the radius. We know the height of this can of soup is going to be 18 because this is a cube box. Okay, because you can tell this is 18, 18, 18. So the height of this box is 18. Now we need to find the radius of this can. Now, if I was to redraw this from the top looking down, okay. Hopefully this will. Something like this. Hopefully that's a good enough looking square. So this is a square with sides 18, 18 and 18. And now you have a can, there's 4 cans and they fit perfectly into this box. Okay, so that means that the cans are all touching. Okay, so that means that this is so diameter of 1 can and diameter of 2 cans will be 18. So the diameter of 2 cans is 18. So this is 18. So that means that the diameter of 1 can must be 9, which means the radius of 1 can must be 4.5. So from this, I'm just going to move this, whoops. This is a top-down view of the box. Okay, so we move this over to here. Alright, so to find the volume of 1 can, we're going to have pi r squared times height. Pi, we just leave it as pi. R squared, we know R is now as 4.5. 4.5 squared times the height, which is 18. Now what's 4.5 squared? And then we times it by 18 and that'll give us, it's equal to 364.5 pi. Again, I didn't multiply the pi in, I left it with the pi there. I want the exact, this is the volume, the exact volume of 1 can of soup. Now we have 4 cans of soup, so the total volume total of all the soups is gonna be 36, it's gonna equal to V1 times it by 4, which equals to 4 times 364.5 pi. So multiply that by 4 and you get the volume, the total volume is equal to 1458 pi, exact. But they want it to the nearest centimeter cube. Alright, So multiply pi with this number and get the decimal equivalents, and then just round it off to the nearest centimeter cube and done. Question 9. I'm gonna move this a bit. Okay. For each cylinder, calculate the volume correct to the nearest centimeter cube. Okay, this is easy. Remember, to find the volume of the cylinder, we just have to do pi times r squared times by the height. You're given the r, you're given the height, so just plug the numbers in. So there'll be pi times r, which is 6.7, okay, squared, times it by the height, which is 15. Put it into the calculator and get the answer. And do that for all of these. These are all, oh, hold on. That's just the first part. The second part says find the capacity in liters. Okay, so let me do a demonstration of the first one. So I'm gonna find the volume of this one, which is 6.7 squared. Whoops, squared times 15, and you're gonna get 673.35 pi. Now we multiply that in, the pi in, and we're gonna, this is the exact volume. Okay. Now we're gonna find the volume. So we're gonna multiply this by pi, and you will get 2115.39. Now this is in centimeters. All the units are in centimeters, so this will be centimeters cube. Now to convert it to liters, we know that 1 centimeter cube is equal to 1 milliliter. So this is going to equal to, let me just change this one to color so it looks better. So this is going to equal to 2115.39. Does it say to the nearest anything? Oh, to the nearest centimeters. Whoops. Okay. So let me just change that. This will be 2115 centimeters squared. Cube, sorry. And now to find, that's going to equal to 2115 milliliters. Now they want it to the capacity in liters. In liters. All right. So now that we change it to milliliters, we can change it to liters. So remember that one milliliter. Actually, I'm just 1 milliliter is equal to one. Sorry, not one. Okay, let me do it again. Remember that 1000 milliliter is equal to 1 liter. So to get to liters, all we got to do is just take 2115 milliliters divided by 1000, and you're going to get 2.115 liters. There you go. This is the capacity. Capacity is usually in terms of milliliters and liters, whereas the volume is usually in terms of centimeters squared or meters squared or stuff like that. Okay, and you just have to do that for the other two questions and you're done.